Hello, welcome back again. We just left at a random or probabilistic sampling. Now let us look at the non-random or non-probabilistic sampling methods. So the main difference between probabilistic and non-probabilistic sampling is that in probabilistic or random sampling, there is a theory of probability backed by two factors. First one is the equal chances of getting selected, and second one is every selected individual or element should be independent of other units or elements. So in the case of non-random, you don't have theory of probability. So that's based on your choice. So whatever population that you're choosing, it's mainly based on your judgment, your purpose and all. So another way, another application of non-probabilistic or non-random sampling is that if the population is either unknown or cannot be individually identified, so in that case you use non-probabilistic sampling. So two things here: it doesn't follow the theory of probability, meaning it doesn't follow the theory of equal probability of selection, and the other one is that it doesn't follow the independence of selection of that unit. So the second one is that the population should be either unknown or cannot be individually identified. There are lots of commonly used sampling designs, but five major commonly used sampling designs are quota sampling, then accidental sampling, then we have got purposive or judgmental sampling, then we have got expert sampling, and we have got snowball sampling. Some of the sampling techniques we looked at in brief in our unit 2, lecture number 1, but we are going to look at these things in more detail in this one. So all these sampling methods can be used both for qualitative as well as quantitative methods. In qualitative, use the sampling techniques to take your predetermined sample size, but in case of qualitative, you use the sampling technique until you reach the data saturation point. The first one from non-probabilistic or non-random sampling is called as quota sampling. So meaning you keep the quota, or you keep the sample size that you want to take in case of quantitative, or you take into consideration the data saturation point in case of qualitative. So whatever it is, let's take an example of quantitative analysis. So for example, you want to take 30 sample from 100 individual or 100 units. That 30 is your quota. So keep that 30 in your mind. And now we are not looking at random, but we are looking at non-random sampling strategies. So it can be used when you have easy to access the sample population, and when you have this easiness to access the sample population. Let's say for me it's easy to get the sample from forestry third year, because I'm teaching third year forestry right now. So firstly that one. Secondly, how to carry out quota sampling. So to carry out quota sampling, firstly I need to stay at a convenient place. So let us say to study forestry third year, I can stand near the class of forestry third year. I can stand at the door of the third year class. Then what I want to study, for example, I want to study the average age of the class students. So I'll stand near the door and I'll study the age. And then when students leave for interval, or when they leave for lunch, or when they are leaving from the class, I take whoever is coming out of the class, the first 30 individuals' height. So if someone is coming right after the class is getting over, then I'll take his or her height. Second one, his or her height. Third one, his or her height, until I reach the desired quota. So the main thing that you need to know is that you have to have the easiness to access the population. That's for third year. I took it as an example. Secondly, you have to have a convenient place to take the samples. So I was standing near the class at the door. And thirdly, I need to have the character that I want to study. That's age. Then I want to take the required number of samples. So that's 30. And it cannot be generalized mainly. So though you can take the average age of these 30 people, it's not something that you can really generalize. But many people, they do generalize, but you have to know that these results are not something that can be used for generalization. This is exactly what I was talking. For example, if you want to take average income of this group of people, so let's say this group of people are basically tourists. That's tourists that are entering to the country through Paro International Airport. So my sample size is around 10, and I go to Paro Airport, right where they have to check out from the from the airport. So I just stay at the terminal where they have to check out, and until I get my desired quota, that's 10, then I collect my data from the 10 people on the average income that they have. So that's one of the example that I can take. Another example that I can take is, for example, if I have forestry first year, second year, and third year, and forestry first year has around like 50, then it has around that much students, and it has around 30 students here. I can either take proportions. For example, I have to take from the 100 individuals, I have to take around 30 individuals from this 100. I can either take 50% proportion of 30. I can take 15 from here. Then I can take around 8 from here. Then I can take around 7 from here. I can take like that. Or I can randomly take 10. Then I can take 10, or I can take 10. But the main thing that you need to know is that you need to stand at the convenient place. Forestry third year, forestry first year maybe at room number 80 or 81. So I stand at the door of 81. Then forestry second year maybe in room number 90, or in forestry third year maybe in room number 89. So I stay at the door of these classes. Then I take, for example, if I want to study the average age, I want to take the average height of these people. So just know that quota sampling is something that you have to stay at the convenient place and take the samples, that quota samples, until it meets the required number of samples. The second one is called accidental sampling. It's exactly like quota sampling, except that the second part, in quota sampling you have convenience, place, and visible characteristic like age and all, income and all that you want to study, and you do the required number of samples. That's called quota. But in case of accidental sampling, you do not have the middle portion over here. You just have the broad topic. For example, I want to study market structure of Messina. So I really do not have a specific topic. Like I do not have a specific topic like income of every shopkeepers. So I do not have that kind of like specific visible characteristic, but very broad. I just want to see the market structure of Messina. So in that case, I go to Messina, convenient place. I do not have anything else, no guided visible characteristics, but I have the required number of samples in my mind. Let's say 30 shopkeepers. So I just randomly go there. I just choose the 30 shopkeepers based on my convenience. So that's exactly like quota, but we do not have the middle visible characteristics here. And it's simply just convenience and required number of samples. And it's very common among researchers like market research and newspaper reporters. Newspaper reporters, they don't have a specific target in their mind, but they have got broad idea what to get information about. So they just go there and they just select their interviewee from the convenient place wherever they are doing the interviews in. So basically, same thing like quota, but you don't have the middle characteristic. Accidentally, you get something else new. For example, if I have to do a market study of Messina town, accidentally I'm getting new information from that area. So yes, accidental is one of the things that is not a quality of good research, because research should not be very accidental. It should be a planned, it should be well framed process. But accidental sampling here just means to say that you have planned samples here, you have got a convenient place planned ahead, just that you do not have a planned visible characteristic. You just could directly jump there, and depending upon your topic, you directly start asking the samples from there. Third one is judgmental or purposive. Mainly looks at the ability of the researchers to judge whether that person can provide best information to achieve your objectives of the study or not. For example, let's get back to the ethnobotany concept. I want to get some ethnobotany of a fruit X, and to get that, I feel that it's on my judgment that I feel that those people who are teaching or who are doing research in ethnobotany can give me a very good view or information about ethnobotany of that fruit. So I choose those respondents to give or to supply me the information. But again, that's basically on your judgment. It's not sure that they are actually expert or not, or they are actually someone who knows or not. It's based on your judgment, or it's based on your purpose. So it's extremely useful in places like historical reality. For example, if you want to dig some information about past situation, past issues, problems, or phenomena, and you want to pick not the younger generation, because you are judging them, because you feel that they will not be able to give very good information about the past. For example, if I want to study something past related to that village, choosing older or senior citizens are the best method to get this information. So extremely useful for historical reality to describe a phenomenon. For example, if it is some unique phenomenon that can be explained by some kind of like hardcore science people, choose those people. So that's something that can really give you very good information in this kind of fields. It is again commonly used in qualitative research. It can also be used in quantitative research, but just know the distinction. Qualitative research is based on the data saturation, and quantitative research is based on the predetermined sample size. So just judge the people whether they have got the ability to respond to your objectives and needs, and if you feel that they have the ability, just choose them and get the information. If it is qualitative, just get the categorical or nominal information. If it is like quantitative, just get the numerical information from them. So that's on the judgmental. But in case of expert, the main difference between expert sampling and judgmental sampling is that in judgmental sampling, it's entirely based on the judgment of the ability of the researcher to see whether respondents are capable enough or not, or are expert enough or not. But expert sampling is not based on our judgment. Expert sampling is based upon the reality that that person is someone who is expert in that person has got many years of experience in working in that area. That person has got many publications. So you choose to add that person, and depending upon your research methods, for example, if it is like qualitative, just choose experts, number of experts until you reach the data saturation point. If it is quantitative, just choose predetermined numbers of experts, then get the information about anything that you want to study in. The last, not the last, but one of the five commonly used is snowball sampling. This is a process of selecting a sample using a networks, meaning you choose one person, and based on that person's network, that person will choose another person, and another person will choose another person again. And if it is like quantitative data, if your sample size is 30, until you reach 30 based on their recommendation and network, you go on with your study. If it is a qualitative, until you reach your data saturation point, that's it. So firstly, the process is that you choose few individuals in a group or organization, then asks to that few people, get information about whatever you're trying to study, and if you're done collecting data from them, then ask them to choose other people who they feel that they have got, these other people have got information about what you're seeking. Then they will then you ask the recommended people. Then these people are again going to give you information or data that these people again are going to recommend some other people, and this process continues as some kind of like links and networks. And this kind of sampling, which rules, is called as snowball sampling. And the main disadvantage of the sampling is that it can lead to a very strong biasness, because for example, if you want to study the again the effect of environmental policy to the students, the first group of students, if you have chosen for example from class 11 and 12, if you have chosen commerce and arts stream students, first group, they may not be able to give very specific idea about environmental science and environmental policy that they must have been affected. So they give you information which itself is quite biased, and they recommend the next person, or they may not be recommending the science people, but they may be recommending another arts or another commerce students. And again, the next person that is to be interviewed again is a person from a different background again, rather than to have a person from background who has got some environment but is becoming biased in this case now again. So usually it's biased because it depends on the population that you have started. If the population that you have started is not accurate, it's not someone is the population that you are not wanting to be included, then the next person that they recommend is totally again someone else that again they may feel that they can give, but they are not someone that you want information from. So strong biasness can lead from this kind of study, but usually it is very good for studies like communication patterns, decision making, and diffusion of knowledge. So that's all about snowball sampling. And at last, the mixture of random sampling and non-random sampling is called as mixed design, and we have got only one design in the mixed design. That's a systematic sampling design. So in systematic sampling design, you have got both aspects of random and non-random samplings. The process is, firstly you divide all your respondents or all your plots or all your data collection units with segments called as intervals. So you just give them random numbers, not random numbers. You just give them numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and all. Then secondly, you decide the interval that you want to take. For example, 3 people interval, or 3 kilometers interval, or like 4 kilometer interval. In case of national inventory, national forest inventory, NFI, the interval between two sample plots is 4 kilometer by 4 kilometer. That kind of interval is being chosen. Then the first sample is chosen based on the random selection, simple random selection technique. Then the next sample that you are going to choose is based on the interval that you have already decided. So for example, number 2 is randomly chosen. Then if the interval that you have set is around like 2, then now next one that you have to follow is non-random. So first one is random, and the second one is basically non-random. Or if you want to choose again 3 kilometers between or 3 plots in between 2 sampling plots, then first one is random and second one is non-random. Again, third one is non-random, fourth one is again non-random, fifth one is again non-random. So this kind of sampling technique was studied under random sampling method, or sometimes under non-random sampling method, because it has both aspects of random as well as non-random. But you have to know that because of this combination of both kind of sampling designs, it's placed under mixed design. Thank you so much for this one.